My name is Laurent Thomas. I'm working as a software developer for ACQUIFER. ACQUIFER is a microscopy company based in Heidelberg. You might know us for the Hive. It's a centralized workstation for data storage and processing. But we also have our own microscope. It's an inverted wide field microscope, the imaging machine that's represented here. And on this system, specificity that the sample holder is fixed and the lid moves on top, so there's no perturbation of the sample. So it's ideal for non-adhesive sample and time-lapse imaging of living organisms, for instance. So since I joined the company, actually doing my PhD thesis back in 2017, we're quite interested in feedback microscopy, automated microscopy, object detection, and so on. And so today I will talk about the Prescreen rescreen workflow that we have implemented in various ways. So this is one way we can do it on this machine. For the sake of the example, so this is the view of the software, basically the control software of the microscope. And for this experiment, whose kind of dummy sample I took, is this Medaka embryo. So it's a model fish organism that's used in biomedical research. Yeah, and here, so I'm just illustrating actually only with bright field. And again, but it's really just for the sake of the example. I could have put additional channel and so on. So the Prescreen rescreen workflow that I'm going to show you, the way we are doing it here is we start with an overview experiment where we image the full well for each well of the plate. So this Medaka are in a 96 well plate. So there is one Medaka embryo per well. There could be more actually. And since they are still in their chorion and round, so they can be in any place in the well or just pipetted manually. Therefore, if we want to image at higher resolution, we can take advantage of this Prescreen rescreen workflow to identify where is the object in the overview image. So the workflow is as following. Then I'm starting with the first acquisition for the full plate, or at least for the top two rows here, just for the sake of time also, where we see the full well in bright field. Then I'm localizing the embryos using some image processing. Here I'm using template matching, which is something that I've been using for a long time now. And from the position of the object in the image, then I'm converting this to kind of microscope coordinate that the system can understand. And I'm then replacing this position into, let's say, template protocol for the rescreen at a higher resolution. So basically, for this pre-screen and rescreen, as I was saying, I'm using a kind of template experiment that can be generated via the graphical user interface. So you can configure basically what objective to use, if there are any autofocus settings, what channel to use, if you do a Z-stack or just a single plane. And this gives you a file that's kind of specific to this system with all the settings. So it's here we have two, so I generated two, one for the pre-screen, this 2x script that I coded, so it's a custom file format, and then a second one for the 4x acquisition. And so in the first part of the script, so this is basically I didn't mention it, a Python script basically that's going to run this workflow. So it's going to orchestrate basically all these different steps together to make it a fully automated, basically pre-screen rescreen workflow. So the Python script could be run in just one go, and it would do everything in automatically. But here, just for the sake of the example, so I will show a video on the next slide, and I run the code basically block by block, so we have a bit more of an idea what's going on. So the very beginning of the script, basically, I'm importing some package. So we have some custom package that allows to communicate with our microscope. It's available on PyPy, so the public package repository for Python. I'm then defining what script I want to use for my pre-screen and rescreen, and the very first step then is just to start the rescreen. So for that we have a single command. So I'm just creating first a connection to the microscope with this first command. scope equal to TCP/IP. So that's basically the underlying technology, but that's not really important. And then telling to the microscope to start this prescreen. These commands basically will then just block. It will wait until the acquisition is done for the rows I selected. Once this is over, I get back the directory where the image were saved. So I can look into it, do the object detection. So here we have a bigger block, which is just about finding the object with the template matching. And then for each detected position, I'm creating this so-called pixel position. You can see my mouse actually, or?
Yes.
Yes.
Yeah, okay, perfect. So I'm creating here this custom object pixel position, which I'm then adding to a list. And then at the very end, I have this command replace position in script file. I mean, the naming, I just came up with it recently. I guess we could find a better one. But the idea is that it takes the template script for the 4x rescreen acquisition, and it will update the position or contain into the script with the one from the detected object. And then same story at the very end, we just run this script with a new position, this rescreen script. Okay, so that's about it. Then the video, how it actually looks like. So this is, as I said, the view of the software. Then I jump into Python, running the import, and just so that's not really important. Loading the template file. So here I'm highlighting that I will run the prescreen script. So there we go. So you see that this run, and now the prompt didn't return. It will wait that the acquisition is over. So that started now. So some wells are empty actually in this plate. That's actually I mean, it's not typically the case, but that's kind of a use case. Because then with the template matching, I can actually automatically filter those wells based on the score of the detection. So the empty well typically had lower score. Also, maybe one word actually about the sample here. It's actually very well prepared that the sample were quite in the center, but typically this can deviate. Or for other sample that could also be used where, I don't know, we want to look at some larger organism and a specific organ, then the template matching would make more sense. But this again just for the sake of the example. So this now returned. The command return also the directory of the image, so I can look into it. So on this system, we get basically a single TIFF file for each plane that was acquired. Okay, and then for each of these images that I said, I'm going to run the detection. So we have a for loop running the template matching on each well. It's a bit small, but I would share the file after. So this is the result of the detection. We get basically a bounding box and a score for each of them, and also save the detected region just for controlling. And finally, replacing then the coordinates into the second script with the coordinate of the detected objects. There we go. So you see in the preview on the top right that the set of wells were actually already updated. So now we are re-imaging at a higher magnification with a 4x objective. I could have put additional channel as well, but again, here for the sake of simplicity, just put a single channel and a single slice. And again, then we get back the directory where the image were saved for this rescreen experiment. I think I'm just also, yeah, just going to. So here basically get a bit better resolution. All right, so that's about it. Yeah, I think the video will just play again. Just go to the next slide. So maybe to conclude about this way of doing the pre-screen or rescreen, the advantage is it's relatively simple it's like high level for the communication with the microscope, so you really don't have to worry about addressing every component. It's really just a single command, this run script. So for the user, it's not so much effort. Basically, if he wants to update the parameter, he can go back to the GUI, update them, save the script, and just update the path in the Python script. It's also not too complex. So we have this single Python file and then the script file that we need. On the other hand, it's a very sequential order now that I showed you. You know, we first image the full plate, then only we do the image analysis, and then finally we do the rescreen. There is not like a event or a kind of real-time feedback, and also no direct access to the microscope parameters. But that's one way to possibly do it. We can actually do also on this system the more lower level where we address each component, but the code would be a bit more complex and a bit longer. So just to conclude on this system, so as I said, there are different ways to control the microscope. So you can do it via the GUI, obviously. We also have an internal scripting language. That's also an option, but it's in C#, but it's maybe not the most user-friendly. Then we can do it externally, like via Python, like just as I showed you now, but this can also be another application at Java. And we also have a visualization software which has some kind of automated microscopy solution as well, or semi-automated, so you can kind of first view the detection, then manually correct if you need, and so on. So that's about it for my side. Is there any question then on what I just showed you?